General relativity, step by step. Right, we've done these terms here. We've got these cross terms here. Minus. Blom, 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 blom. That's this term here, which is the negative. I'm going to put the plus underneath here. I don't want to extend anything else. Dong, 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 dong. See, I just write the skeleton in, and now I'm going to start thinking about how it works. Okay. This sigma here is the n, which sums with this n here, which is a nu. So that second term in the second Christoffel symbol, it's written sigma, but I'm going to call it nu. That alpha's free, which should be red, I guess. Alpha, nice and free. That's a good one. Done that. Just go back to black. This term here is a mu. Which sums with that one there. So I may as well, oh no, I can't, because I've used a mu here. I'll call it something else. I'll call that one pi, just for the hell of it. And what have I got left here? I've accounted for that term there, and we've got a mu and a sigma, which are going to have to be, the mu and the sigma are the u terms, so it's going to be mu and sigma, summed over pi here. So that's that term there sorted out. Playing fast and loose with my indices here. Right, where's my free one? My free one's on the first one, so I'll go to red. There's my red, that's alpha. Go back to black. Let's do the n term first. Just noticed a mistake. I had a u written down there, and that should be an n. Alright, how does that make things change? Well, this n has got a gamma, and the gamma should be a nu. So where I did have gamma written, I'm going to write that gamma is going to be a nu. So it sums correctly with this one here. We've got... what's on the top? Oh, the top one's summed, and I've called it nu, but I'm going to call it pi, simply because I can. And that's this term here, which is that there. And what have I got left? I've got the two terms sigma here and beta, which go with this one and this one. I've called them sigma and beta here. I'm going to call them sigma and mu here. Sigma and mu. Good grief. Okay, so everything checks out. Alpha's the free index, which I've written in red. I'll put it here as well. Dian, oh, it's second derivative, di tau squared. And in red, I'll put my alpha term there. Now, those of you who remember screencast, I can't remember what number it is, but I defined the Riemann tensor to be this thing here, or actually the negative of it. There are different sign conventions. So this thing here is the Riemann tensor. So let me just write down the whole thing again. d2n by d tau squared alpha equals, and there are different sign conventions, so I'm just going to call it a minus r. Alpha up there. Underneath we've got mu, we've got nu, we've got sigma, which go with u sigma, u mu n eta. And there we have it. We've gone through a huge amount of algebra here. Look at all this. It just goes on and on and on and on and on. It's complicated stuff. When Einstein said he was lost in the indices, this is the kind of thing he was going on about. This is the kind of thing he was struggling with. And he spent years and years and years being lost in the indices, and you can see what he means. There's a lot of algebra here, and you need to have your wits about you. Anyway, we've got this nice equation here, and I'm going to stop there, and I'll interpret it in the next screencast. Stop. Beautiful. Stop.